Okay, what we're going to do now is we'll finish around 3 o'clock, I think. We are missing one of the presenters we had for this session, so that makes it a little shorter. But what I'd quite like to do is bring the focus back onto the Alias project, actually, which is what this is all about for me. I think we've had over the last couple of days an excellent sweeping view of RPAS and ACAS-X and a number of all sorts of different issues surrounding them, and that discussion honestly could have gone on for an entire week, I think, with all the questions and issues. But as I said at the beginning, our focus was not really on the technologies, but upon how the Alias tool or the legal case tool and how Alias were looking at those and whether it was effective. I think for RPAS, I got a general sentiment that the process was positive, and I think when we saw the analysis done by Giuseppe particularly, there were many suggestions came out, which I think some might have already been intuitive, but I hope some of them actually derived from the exercise that you went through with the legal case. And the feedback we got for RPAS from the members of the RPAS user group, RPAS panel, was rather positive, I think, in all cases. ACAS-X was a little more mixed, I think. We had a specific focus on on a particular design choice. Again, a number of recommendations came out, but the sentiment that actually there was very little guidance, feedback into the design process that would have necessarily helped that. So a slightly more mixed outcome from that, I would say. I think, you have, whenever you introduce a piece of technology, and we've seen it many times in recent years, a technology has been introduced and it is used, but not necessarily for exactly the purpose for which it was designed. And I could give you a number of examples. And I think one of the things we've seen here is that the legal case tool has been an extremely useful way of discussing around all the issues, not just legal, not just liability, and has been a real eye-opener for the people on the user panels on the issues involved. And even I think one person used the word shocked by when she learned of the legal process. Others have lost all faith in the legal process and so on. So in that respect, that's a bit of a byproduct. But one thing that was obvious, I think, was that both RPAS and ACAS-X provided different kinds of challenges. And so what I'd like to do for a little bit, just for a few minutes in this last session, is to maybe look at other kinds of applications, other legal challenges for different kinds of automation, different kinds of technology. And really, the advice to the Alias project for its last 6 or 9 months is to try and, I think to make it work, you have to try and characterize the kinds of automation, the kinds of technology that are suited to the application of the legal case tools, and by the same token, find the kinds of applications that actually don't work so well. Because if you come to sell the tool, if you try and get industry or whoever SESAR to pick up and use the tool, you really need to go with good examples that are actually going to work, and not any old example that actually you have to explain and you end up apologizing because it's not really appropriate. So my advice to the Alias project would be to really try and characterize the sorts of applications and technologies that work well with the methodology that's been developed and the tool that Patricia showed us yesterday. How exactly you classify those and characterize them, I think you need some sort of set of rules or some set of dimensions along which you can classify them. But that seems to me quite important. So what we're going to do now is have a couple of presentations. One is from Marc Bourgois from Eurocontrol, who will start, and then Alberto Pasquini from Deep Blue. Marc is going to start off looking at experience from SESAR long-term and innovative research, I guess work package E stuff, And okay, I'll just hand you the floor, Mark.
Thank you, Colin. So I'm going to put the Elias project in the context of all the projects we do in Work Package E in this funding scheme for long-term and innovative research, and to show you where we want more and less and what kind of ideas come maybe from other projects to the legal field. So challenges for the future, not necessarily on liability, but on other issues. My presentation is very short, but I'm just going to give you a bit of an overview of the kind of projects we do so that you get an idea of how many are non-technical, how many are technical, and so forth. Then some what we call transversal issues, issues that pop up and that are maybe enablers for change as well, like IPR, open source, open data. These are issues that many of the projects struggle with and would be enablers for more research, but not only research, also services and operations. And then I take two specific projects with which I've been debating a bit over the last few weeks, because they have suggestions for legal issues that have popped up in these projects. Now, I'm not the one following these projects, Colin is by accident, so I cannot go into much depth, but it shows you some of the issues they might want to raise. This is just the thematic program we had for our first call for ideas. And these were all the possible issues we thought would be areas for research. Now, in the end, we down-selected this to 4 real areas where the call actually was open in. And this was with the idea that since we don't have tons of money, let's better focus on a number of issues which are the most urgent or where we need more new input, where we've always been seeing the same things being done again and again. So we ask now for explicitly for innovative input. And so these were towards full automation, so you're partly in that area, but not the technical side of it. Exploitation of 4D trajectories, which was very hot when SESAR came up. The 4D trajectory issue was the major issue. Mastering systems complexity, that was another type of science that we thought might maybe contribute to ATM. And then from the very beginning, we were very clear that if we want to accelerate change and innovation in ATM, we don't need to look just at technologies. There might be other things that enable changes, like economic regulation or legal ways of speeding up or taking away barriers to implementation. And so we had a cluster at that moment which was called economics and performance to kind of look at overall system enablers. Now this has evolved. We did a second call, but essentially the only thing that really happened is that we had even more themes. So the message is that, and this is the call for the schema for the third call, is that in technical subjects you're not limited at all. You can almost suggest anything as long as it is a bit innovative. And even the innovative aspect is being reduced in the last call because you can now do mainstream work more or less as long as it has a long-term perspective. But we maintain the areas like economics, legal, regulation. Regulation in the beginning was even excluded, but now it is part of the scheme. And you see that on the left-hand side where you have the excellence of science, which is the equivalent of Work Package E before, so to speak. So these topics are still open for research. We have a call about every 2 years, and the call for which this was the basis has just been evaluated, and we think that the SGU will make the winning projects public before the SITS, so before beginning of December. The people that submitted proposals will know whether they've been selected. And I think it will be with a rhythm of 2 years there will be further calls, so you can expect in a year and a half or something another call for projects. Now, it's not only projects that we do in Work Package E, we've also been creating networks, and that's the clusters you see, the 5 blobs around. These are like clusters, these are the teams that you've been seeing before, and we have large clusters on mastering complex systems and on automation, and both of them were supported by a network with explicit funding because they're big communities. Now, we're very happy to have seen in this area that the project kind of instigated its own little network, and it's not so little. I've been very surprised by seeing about 40 people here at the beginning from a very varied user community, and that was a very good aspect. So I think there will be intermediate calls for research facilitating activities, and I think that networks will in some shape be called for within the next year by the SGU, so that this kind of activities can on their own exist. Now it is up to you whether you think that you have the critical mass to really create a real network, or whether you want to embed it in a project in the future. That you have to see. Another thing that you want to notice on this slide is that we had about 6 projects that we would qualify enabling change in ATM, which are non-technical. They are economical, regulatory, legal. They fall in that area. So 6 on 40, it's not negligible. We would have wanted more. We would have wanted maybe half of it, you know, because we think that really these are things that can speed up innovation and adoption of technologies. But 6 is not too bad already. Now, in practice, this is how the projects map onto the original call. A much better way is to show where they are logically clustered in terms of their topics. But we've only done that for the first wave. But it's different from the call, because you ask for certain proposals, but then you get them in the areas where you might not have expected them so much. Now, this brings me to, you've now seen the context. There were 40 projects, 6 on enabling change, 1 legal. So the majority of them are technical projects, and they provide new technologies, prototypes, and so forth. And some of the issues which have a legal flavor to it, I'm now going to elucidate a bit. I've taken here 3 projects, which by accident were in my area of responsibility, which have produced prototypes, right? Now, prototypes, if you want to really benefit from the research, the more open they are, the more available they are, the more they can be reused for validating the research, the better it is, the faster we're going to advance. And these 3 projects have chosen completely different ways to make their prototype available. In fact, the first one has not made it available. They've just said, no, the foreground, whatever we produce, whatever prototype it is part of the consortium. That is their right to do. The European Union allows that even with this research funding, the full IPR falls with the consortium. So that has happened. Other people have taken a more open source approach. Open source is important because it allows people to reuse this kind of software. It allows a community to exist around a certain area and to advance more quickly, because you don't have to start from scratch again. And we have seen projects where in the first phase, each of them had to recreate network editors or whatever, some tools that everybody else, simulators to some extent, that would have better have been shared. Now, there is a whole science of open source software licensing, and there is maybe a study to be done as to what would be the most fruitful to share this and to make this available, because we've had a workshop many years ago already in Eurocontrol in 2005. We organized a workshop on open source software in ATM as a path for new providers, small companies, to enter the field, because the ATM systems are dominated by an oligopoly, if you want. There are 4 or 5 real providers, and the small ones have no chance. But maybe they have little pieces of software that they could hook into, and by opening the interfaces and so forth, people could benefit and start to use their tools. And it's very interesting to see that at that moment we had, for example, Philips come up from their, I think it was their medical division, if I remember correctly. And they had a bit like you did here. You can then start to engineer liability, shift it from one stakeholder to the other. They were engineering their licenses so that they would release that part of their contribution to the community, which they thought did not give them a competitive advantage. But they would think, if we give this to the community and everybody gives a bit, we will benefit. We will have a software community that advances the tool. And then we were engineering behind some kind of firewalls, if you want, the parts that gave them competitive advantage. So they were playing with the licenses, playing with pieces of software that were bridging, because some of these licenses are very dangerous. They're viral licenses, and if you adopt some of the software from somebody else, you have to make your software entirely open again. But there are ways to engineer around it. But I think that, this was 2005. Open source communities in ATM have been tried again and again. They've not been very successful. I think there is an area of research there to study why this has not happened. Could this happen? How would we enable that? And so forth. So open source software is an issue that has come up with those projects that, my 10 minutes are up, with those projects that have produced prototypes. Now, today it's not just open prototypes, open software, it's very much also open data. And it's a similarly complex minefield. And we've already done a study also about openness of data in Europe compared to the US. And it's very clear that openness of data, if mandated, for example, could facilitate a lot of research and services that currently are not possible because some of the players in the ATM field maintain this as confidential data. The US has drastically different attitudes to these issues, and they mandate certain data to be available without really jeopardizing the commercial operations of some airlines, for example, which are mostly the ones opposing open data. But a lot of research is possible if your regulations are clever and if you mandate certain availabilities. So that is also an issue to see how more openness of data could facilitate not only research but also services in ATM. So that would also enable some change and some expansion. Now, more concretely, I picked two projects, and again, I quote there the people with which I've been conversing over the last 2 weeks to understand the issues a bit better. This project is ProGA. It's about a collaborative detect, avoid, and separation tool for general aviation. And we have pilots and private pilots here in the audience, so I'm going to stay really at the distance of this issue. But it's clear that private pilots are using equipment which is not certified. This has all kinds of legal issues, if ever. It gives them greater awareness, but they also take decisions based on that information. So there is an area there clearly identified by this project. And it's not just the equipment, it is also the data. They share data, they use data which is not certified, but it still helps them to operate, they feel. So there are issues there. It's to a large extent, of course, limited to general aviation at the moment. In major airlines, they wouldn't dare to take their PC and their Google Earth and taxi on the airport service, but general aviation does. So these are the kind of issues that are being raised by this project. And then to conclude, a project which is, I put 3 C's in there, it's just 2. Accelerating change, and by regional forerunners is by looking at areas where change is happening more quickly and learning from those and expanding them over the whole European area. These are more debatable. I personally feel whether they are new topics. These were economic studies, economic regulation studies, markets, can markets evolve and so forth. They were that kind of studies. A very good project, by the way. And one of the things they identified is that ANSPs could be commercialized to a greater extent. We know that. And the kind of issues that raises are that non-governmental bodies have to start being responsible, take insurance and so on. We've mentioned the issues of insurance here today as well. And even more dramatically, it might be that some countries fall without their own service provider, and the service provision is being provided by a service provider from or in another country, which raises all kinds of sovereignty issues, which the Uberlingen accident, for example, has also shown, because there the airspace was unofficially, let's say, delegated to the neighboring state. So these are kind of issues that this project has identified. Now, they also do a lot of market-related issues. They look at why the FAP succeed and not, and whether the regulation was effective or not. And they hypothesize that if you take the most dramatic step in the trajectory concept, which actually would mean that you're being controlled by one controller from start to the beginning for your trajectory, there will be all kinds of legal issues when you have the controls to interface with the different trajectories. There is not a sector-based solution like today where you're responsible for a certain area. You're responsible for a number of aircrafts, which might be interfered with a number of other aircrafts which are under the responsibility of another controller in another company, potentially. So there are all kinds of issues that are related to this more dramatic concept, which was originally foreseen for SESAR. So this is another suggestion that Nicole in this project made. And I think that by and large, we don't see many concrete proposals. I think the ProGA one is the most clearly pinpointing to new legal issues. This one makes some issues which essentially we were aware of to a large extent. But it's difficult to come up, but we don't need tons. We need 1 or 2 more legal studies in the next wave and so forth. So I think the suggestions are roughly there. If there are other projects and people are involved in those and they think there are subjects like that, I think in this discussion now we should raise them so that we take note of them and that in the next call, in the next proposals, we would like to see more of such ideas being brought forward. And with that, I conclude.
Thank you, Mark. One of the big potential liability minefields is provision of data, of course, of which we have plenty of highly variable quality, I think, that is currently circulating and that will increasingly circulate in the coming years. So that's a very important thing to raise. Any questions for Mark on that presentation? Then we will press on with Alberto.
This is one of the network that Mark mentioned before, is the ALA network. The ALA is a network that is funded under the SESAR long-term research work program, and the purpose is to support research in ATM automation in general. Essentially, it has 3 main aims, this network. One is to create a community of young researchers and to support a community of young researchers, the creation of a community of young researchers. This is done with activities such as summer schools or PhDs that are sponsored by the network. Then is also supporting the projects that are in the area of automation. So it's a kind of transversal action that is addressing all the projects that are in the area of automation. So essentially this is done with conferences, workshops, or other networking opportunity. And also provide information to the other research with a position paper website and other initiatives. So this is the activity of the network. While doing this, the network has, let's say, as I said, is supporting SESAR project. I try to, let's say, cluster those projects, especially in 3 areas that could be relevant, to think where there could be a contribution of alias in these 3 areas. One is resilience and management of system degradation is one big area where automation is, where there are projects of automation. Another one is human-machine interaction, also the level of automation delegation. The other one is trajectory management. For all of these, if you look at the ALA position paper that is available on the website, you will find a lot of information concerning this project. So let's look at this. My presentation is just 3 slides, one per topic. If you look at resilience and degradation, you have projects such as SPAD, Scales, or ZEFMAP. The typical problem where we could think to something like the work done in alias is resilience. Resilience is in general as the ability to maintain the service in spite of disturbances, whatever these disturbances are. The difference with safety is that usually safety is risk-based. So you try to understand which could be the risks, the possible risks. You try to estimate the probability of those risks and the consequences, and then design the system accordingly. With the resilience is much more ambitious, and this is why is also plenty of failures, let's say. Resilience is much more ambitious because you want to prepare your system to deal with whatever the event is, so to deal with the unexpected. It's based on the experience that safety failed in some cases, like, I don't know, 3 Mile Islands, or let's say the Fukushima, or the set of events where something happened that was not expected. So resilience has the ambition to deal with what is unexpected. So to design a system that is very flexible, very reactive, very able to tolerate whatever the problem is. But these are as a big problem of how much resilience is enough, how much flexible is your organization. While in safety, a balance is quite easy because you have a certain set of events that you want to afford, so you can design your system for those events. In resilience, you don't have the events, by definition. The resilience is to deal with the unexpected. So how to design the system and when the system is resilient enough, and what happens if it is not resilient is one of the problems. So how you can, what happens in case of malfunction or degradation when you intend to maintain a reasonable service, but also while ensuring safety, and what is the trade-off between investment for resilience and optimization of costs. If you look at the area of human-machine interaction, human-system interaction, and also the problem of delegation, you have projects such as Mufasa, Hadar, or Nina. All are related with the adaptive interfaces. No, sorry, some of them are related with adaptive interfaces. So how an interface can adapt considering the human mental conditions. For example, Nina tried to understand the human behavior and what are the difficulties or which is the workload that the controller is experiencing, and adapt the interface with the aim of adapting the interface to those human conditions, mental conditions. And again, there is a problem, a clear problem of what to do when how to evaluate if those information are correct and how to adapt the interface on the basis of credible information and how to adapt the interfaces when you have convincing information, and what does it mean convincing information in that specific context. Trust and credibility of information provided by the system, by the operator when you increase automation, and decision about the appropriate level of automation. These are the area. And regarding this, there was an interesting workshop that was done by ALA at the last ATM World Congress. This was about crew reduction, pilot reduction, and the support that the controller could give in case of the crew reduction. So these are aspects that were investigated in this workshop and discussed in this workshop, and also in a project that is related to crew workload reduction named ACROSS. It's a large IP project sponsored by the by FP7. And there you have the problem of delegation between pilot, controller, and automation. So some function of the pilot could be delegated to automation, and could be delegated in some cases to the controller, or to a ground support. You have, of course, the problem that may happen in case of malfunctions or unexpected conditions, and in case of a reduced pilot operation, also the problem of deciding about incapacitation of the pilot, and when the pilot, the decision has to be passed to an automated system or a ground system or a ground controller. I don't have anything about the trajectory management, because that is the other area, but it's not very strong in trajectory management, unless, this one. So in general recommendation for alias, I think that the creation of a community of stakeholders was a big result of alias. So the recommendation is to continue this activity with a community of stakeholders, but maybe it's time to switch to considering the different roles of those stakeholders. So let's say legal experts may have different needs and need different information and different interaction than managers in charge of taking some decision may have. So I wonder whether the remaining of the activity of Alias should also try to address, to be more focused on the possible different type of stakeholders that you have. Probably a better dissemination of results between SESAR projects and also in particular with the deployment part of SESAR. And I also have the impression from what you have done till now that there is the need for each different application of populating a legal database of information about that application. And this is something where is now has been done for ARPAs and ACAS, but is probably needed to be done also for other cases if you want to expand the use of the method and the tool. And that's all.
I think so with Mark and Alberto's presentations, there are a few hints of other areas where, and broadening to overall more general legal considerations as well. Just struck me on the question of we can consider also procedures rather than just technology. You recall that we based a lot of the SESAR work on the idea that traffic would increase by 3 times, would triple by 2020 or whatever it was, 2035. But now actually it's only possibly going to be plus 50%. Now, to absorb an increase of 50%, actually, you don't need much technology. If you change procedures in the ops room, you change the way you sectorize, you populate with controllers at different times of the day and so on, you can, I understand, create significant additional capacity with no extra technology. But, of course, that might come with other kinds of risks as well. So maybe there would be a way of adapting the alias methodology to look at more procedural changes rather than just technology. I've written down another, again, as I said, you know, I think it'd be really good to understand what kinds of technology and automation are well suited, and you could consider things like controller tools, conflict detection and all these kinds of things, which are still not fully implemented by any means and have been largely misused when they have been implemented. So there are issues about if you introduce a technology and it's actually used for a completely different purpose, how does that affect the liability issues? ASAS was a classic one, airborne, help me Ken, autonomous airborne separation assistance systems, where there is an actual delegation of separation responsibility at some level to the pilot. This was a big deal some years ago. It's fading away a little bit, but there are some clear liability questions which arise from that. Virtual tower, the integrity of data, for example, which is essential to be able to run virtual tower operations, and maybe the non-immediacy of the data updates. Sharing data within airports. I'm astonished that collaborative data sharing in airports is still very poorly happening at a very poor level across Europe. But if data is shared in airports, but particularly critical data, that could have issues. We have new rules concerning wake vortex separations, the RECAT rules based on a certain set of calculations and physics and understanding of the way aircraft behave and the kinds of vortex they leave behind them. Virtual centers is another good one where data and information is shared across national boundaries, and at any one time nobody might actually know who is responsible for controlling a piece of airspace. That sounds like a lot of fun. SWIM, of course, and all the data related issues that Mark just mentioned. SWIM again will be in principle an international will have no frontiers, no boundaries, subject to maybe several different regimes in different countries. So areas of responsibility, liability, legal issues could be substantial there. Just mentioned trajectory-based air traffic control, where you don't have sectors or centers, but controllers are assigned specific aircraft to see them through, as happens often in military context, see them for the entirety of their flight. All these kinds of subjects. So for Alias, you could consider one or two of these and say, yeah, this is something where we could really use this tool and produce some interesting outputs that could guide the research. How do you characterize these changes? You could characterize them at their level of maturity. You've said often that you want to get in early in the development cycle of the project. That wasn't the case with ACAS-X in one sense, maybe ALPAS, I don't know. You could characterize by somehow the nature of the technology, by the degree of human involvement, despite the fact that you've used the LOAT, by the potential for fatal incidents that is implied by the technology. And the other thing, just to finish my comment, another thing you haven't done actually, you focused specifically on potentially fatal accidents. Other liabilities are increasingly becoming politically sensitive with regard to, for example, delays and the costs of delays to passengers, with regard to environmental effects of the way we operate. Think of Volkswagen in the last couple of weeks. Even liabilities for failure to implement SES policies such as functional airspace blocks and so on and so forth. So, okay, you can't do everything, but fatal accidents is one thing, and the biggest thing and the most catastrophic when they happen, but they're relatively rare, and there are other kinds of liability issues which might be precipitated by the adoption of one or more of those kinds of technologies. I don't know if anyone else has any comments on that, or on actually anything else that's been said in the last day or so. Are we all exhausted? We've had enough. Okay.